Okay, kids, the lesson we're going to do tonight and into tomorrow is called Polynomial Long Division. You recall back when you were in 3rd, 4th, 5th grade, probably 4th and 5th grade, where your elementary and middle school teachers began to teach you how to perform long division with whole numbers. And writing the number of times the divisor went into the dividend, and you know, it's a pretty long process. Well, we can do the same process with polynomials, so we're going to show you how to do that. So if you could, just take a minute, pause the recorder, get these notes copied down, and then we'll talk about them a little bit and show you how to perform long division. So go ahead and take a minute and go ahead and do that. We'll be with you. Now for polynomial long division, the notes are worse than the actual process. If you go through it, it says write the first polynomial inside the dividing bar, the second polynomial outside the dividing bar. And then you ask yourself, what do I multiply the first term in my divisor by in order to get the first term in the dividend? This is very similar to what we do with long division with whole numbers. And so what I'm going to do here is I'm going to scroll this up. I'm going to move this down a little bit. We won't need that right away. And I'm just going to write over to the right over here. I'm going to make up a problem and show you how similar it is. Let's say that we were dividing the number 412 by the number 7. And so if you were going to do this, the first thing you'd say is, well, how many times does 7 go into 4? It doesn't. And then how many times does 7 go into 41? That's 5 times. And so you write the 5 up above, and then you would multiply the 5 times the 7 and get 35. And then you subtract 41 minus 35 and get 6. And then you bring down the next digit. And then you would continue the process. 7 goes into 62 8 times. 8 times 7 is 56. And then you subtract and you get a remainder that is less than the number you are dividing by. And so in that case, they would have you write this answer 3 ways. Way back when you were little, they first taught you just put a little r here and a 6. And of course, you didn't know what fractions were at that time. And so all that meant to you is the remainder is 6. And then when you got into fractions, they taught you how to write the remainder over your divisor. And so now your answer is a mixed number. And then finally, they would teach you how to write the answer as a decimal. They taught you how to put a little decimal point here and relocate it above. And then you would start adding zeros and bringing zeros down. And you would go ahead and continue with the whole process until you rounded to a certain number of places. Well, what we're going to do tonight is we're going to write all the remainders as fractions. So I'm just going to leave this here as 6 over 7. And now we're going to come over here to problem 18 from the assignment and show you the similarities in the process. So first, you take the, if you look at your notes, it says look at the first term in each polynomial. I'm just going to underline it right here. What would you multiply to x in order to get x squared? And the answer is, of course, you'd multiply x times x. So we write that x up above, and now we multiply the x times the x, and we multiply the x times 1. Now, in step 3, it says write the factor above the dividing bar. We did that. In step 4, it says multiply this factor to each term in the divisor. We did that. And now it says subtract the terms. So if I subtract, I'm going to put this in a different color for you. If I subtract this and subtract this, now when I go to perform the subtraction, the x squares cancel out. Negative 6x minus 1x is negative 7x. Now over here on the right, after we subtracted, we brought down our next term. Over here, on the left, when we subtract, we don't bring down the next, we don't bring down the next digit like we did over here. We bring down the next term. So this is going to be negative 7x plus 4. And now you just simply repeat the process. What do you multiply x by to get negative 7x? Well, that would be negative 7. And now when you multiply negative 7 times x and negative 7 times 1, this is what you end up with. Whoa, that happens once in a while. I've got to go slow with this. And now you have to subtract those. I like to think of it this way. Instead of subtracting, I like to think of it this way. How about if we just change the signs and now add all the terms together? And when we add them together, the x's cancel out. 4 plus 7 is 11. And so our remainder is 11 over x plus 1. I want you to just go ahead and look at that for a minute. I try to put, when I change the signs, in a different color so you can see that. Now, one of the things that I'm sure you're wondering is how come I didn't continue? How did I know when to stop? Well, I don't have an x term left down below. I have the number 11. And we don't know how many times x can go into 11 because we don't know what x is. And so that's our key when to stop. And then the second question students have a lot of times is, well, how do I know I'm doing this right? How would I check this for my homework or in a test situation? Well, take a look at the problem on the right, 58 and 6/7. If you want to check and see if your answer is correct, all you have to do is take 58 times the denominator, that's a 6, carry 5, that's 406, and then add the numerator, which was your remainder. Remember, this is a remainder, so if we add our remainder into 406, we end up with 412, and that checks out. We're going to do the same thing over here. We're going to take x minus 7. We're going to multiply it times the denominator, which is x plus 1. And then when we get done with that, we're going to add that 11 on. So let's FOIL this and see what we get. X times x, x times 1, negative 7 times x, negative 7 times 1, and then we'll add the 11 in as the remainder. We'll add that in. And when you add those together, you do get x squared minus 6x plus 4. So, make sure you have this copied. I'm going to erase it now. So if you need to pause this and write something down, go ahead. I'm going to erase this, and I'm going to also work problem number 26. Okay, so let's take a look at problem 26. We'll bring that back up. I want you to look at the inside bar for problem 26. You'll notice there's a 0x squared there. The reason there's a 0x squared there, because in your book, the problem is written like this. 2x to the 4th plus 2x cubed minus 10x minus 9 divided by, and then we have the x cubed plus x squared minus 5. Anytime your dividend is missing a term sequentially, like here, we don't have a squared term, you have to account for it in the dividend. Just like when we're doing synthetic substitution if we don't have a certain term with a power, we have to put in a 0 for that term. It's the same concept. So let's go ahead and work this problem and see what we end up with. I'm going to start off looking at x cubed and 2x to the fourth. What do we multiply x cubed by to get 2x to the fourth? Well, we need a 2, and we also need an x. And now when we multiply these together, distributive property, you get 2x times x cubed, you get 2x times x squared, and you get 2x times negative 5, and that's going to go here. Now when we change the signs and add, everything cancels out except the 0x squared and the negative 9. Well, since 0x squared is really 0, we really have 0 minus 9 in the leftover part of the problem, and so that's just going to be negative 9. And now that is less than x cubed in terms of powers, and so that's just going to be our remainder. The answer is 2x with the remainder of negative 9 over x cubed plus x squared minus 5. I'm going to tell you what I'm going to do. I'm going to write this so it's a little bit larger, so it looks more like a mixed number. There's your final answer right there, kids. That's long division. We'll work on it more next class. But for now, look over your notes, make sure you understand it, and then tomorrow we'll give you something to do in class, and we'll see how you do with that. We'll talk to you next time, kids. Bye-bye.